AMC 10A 2005, problem 14. How many three-digit numbers satisfy the property that the middle digit is the average of the first and last digits? So, since we're trying to find the number of digits that can satisfy this given criteria, now this criteria can only range for so far. It can only be between B0 and 9 for the digits of the three-digit number. So immediately I know that this is a casework question. And what is casework? Casework is basically trying to evaluate the different number of cases that can be resulting from a certain probability, which is this. Now, we can suppose this to be A and this to be B and this to be C, the three digits. And we know that B is equal to A plus C over 2, or the average of the sum of the endpoints. Now, what is something particular about A plus C? B cannot be 0.1 or any decimal because these are digits in a three-digit number. All digits are whole numbers and they cannot be negative. So only the integers between 0 to 9. That is the restricted range for A, B, and C always. Now, A plus C over 2 must be divisible completely. So A plus C mod 2 must be congruent to 0. So this must mean that A plus C is a multiple of 2. Or in other words, A plus C can be composed two ways. And what are the two ways? Even plus an even, or an odd plus an odd. And these are two, not formula, but two properties that you should always keep in the back of your mind, because these these concepts of what type of numbers resulted from the sum of two other types of numbers is repeatedly tested on AMC. And this will not be the last time you see this. So now that you've been warned, we can carry on with this question. So A and C can either be all even or A and C can be either all odd. Immediately, if we have distincted two possible outlooks for A and C, this is a casework, because we see here that the road diverges into either case 1 or case 2. That's how I know it's casework, and that is what a casework is. So if A plus C has to be an even plus an even number, what are the even numbers between 0 and 9? This is deduced from our conclusions that we have just made. Well, they can be 2, 4, 6, 8, and 0. Yes, we have to include 0. While 0 is neither even nor odd, if C is equal to 0, it will still be an even number. That's why we must include 0. Now think about it. C can be equal to all 5 of these numbers because C is the units digit. It can be anything. So C has 5 possibilities. And what about A? Can A be equal to 0? If A is equal to 0, then the resulting value for this number will be BC, and that's not a three-digit number. So we know that A's range can only be 2, 4, 6, and 8, not 0. So A has 4 possibilities. And since these are possibilities and we're trying to count the total number, we must multiply, which is equal to 20, because it's 5 possibilities and 4 possibilities. The and equivalent is multiply. So 5 times 4 is 20. So A and C, if they're even, has 20 possibilities. So going on the route of case 1, we'll have 20 possible values for A and C in total. Now, what is the total possibilities for A and C if they're all odd? Well, the only odd numbers are 1, 3, 5, 7, and 9. Remember, it's an inclusive range. So since there is no 0, A and C can be any of these numbers. Therefore, we have 5 times 5 to be 25. Now, with casework, we sum the different results that we get from each case. Therefore, the results from case 1 plus the results from case 2 will give us the total number of three-digit numbers that's possible, which is 20 plus 25, which is 45. Now, you might be wondering why, if we add 1 and 2, will give us a total number of possible three-digit values. Well, that is because each of these values are distinct. Remember, B can vary from 0 to 9. So we don't really need to worry about B. All we need to worry about is the n terms, because the n terms determine the entire bulk of this question. And each of A, when A is equal to 2, when A is equal to 4, when A is equal to 6, they will all produce a certain number of possibility that's reflected within the number 20. And that it goes for the same logic with 25, because that's what the casework is. We deduced this when we branched off in the beginning. So we can be sure that the sum will equal to the total distinct, or not necessarily distinct, but the total number values the total number of three-digit numbers that satisfy these criteria. So the answer is indeed E.